Okay, so we are doing 3.5 day 1. Just a heads up, I will not be here this week, so you'll have videos for the lessons. So today is going to be about intersections of different graphs. So we're going to kind of look at this generally speaking and then looking at it with the numbers. So it says the solution to a system of equations is the point or points of intersection. If the lines are parallel, there is no intersection, so there's no solution. Sketch a possible graph of each system. So one is a linear equation, so that's a line, and a quadratic equation, so that's that curve, where 2 points are intersecting. So you have 2 points of intersection, so a curve and a line where they hit twice. And then 2 quadratic equations where they only have 1 point of intersection, so that would be like this is an option where their vertexes are hitting. And then 2 quadratic equations, sorry, I can't read, where 2 points of intersection. So that would be like where they're overlapping, like this is another option. So there's basically a lot of different things could be going on here. You can even have situations where they don't touch at all, something like this. So when we're doing this stuff in terms of numbers, just thinking about the fact that you can have different types of answers where you have none, 1 or 2 different results. So looking at this, first thing we're going to start by graphing. So it says solve the system by graphing. So this first equation here, it needs to be rewritten as a quadratic. So we just need to get the +1 on both sides. So then it looks like this. So that is gone. So y equals x squared plus x plus 1. And then the other equation is y equals negative x plus 4. And then we just need to fill in the table. So we've done this a million times. Just as a reminder to do the first one, if you're putting everything in the calculator, you would put -3 in parentheses squared plus -3 and then plus 1. Remember, the negative button and the minus button are in different locations. I think the negative button on the yellow calculators is next to the numbers in towards the bottom, and I think it's a white button, and then the minus button is next to all the symbols, and that is a black button. So you're going to fill these in, and I am too. And for time purposes, I'm not going to spend a lot of time like having you type this in the calculator. You will practice this on homework, so don't worry, you'll have time to do that. But I'm more concerned about looking at the actual graph. So let's put these points on the graph together after you've copied them down. So take a second to do so. So then once you've gotten those down, I'm going to put the first graph on here. So -3 on the x-axis and 7 on the y. And then -2, 3, -1, 1, 0, 1, 1, 3, and 2, 7. So it should be looking like a parabola. We don't have the vertex, but I'm just going to kind of sketch that in there. And if yours is not looking like a parabola, excuse me. Whew, sorry, I had to sneeze. And it's supposed to be a parabola, you obviously need to recalculate. And then I'm going to use a different color for the other equation. So now I need to do -3, 7. That's actually the same point there. -2, 6, -1, 5, 0, 4, 1, 3, that's another one of my points, and 2, 2. And then I'm going to draw my, that's not 2, 2. Draw my line. So I notice in this situation they're hitting at 2 points. So the solution to this system is the 2 points, -3, 7. That was this point right here. And then also the point 1, 3. So these equations, like we talked about, can have no solution, one solution, two solutions. This situation had two. So the other way we're going to look at solving these kinds of systems is with numbers algebraically. So this next piece is going to be specifically using substitution. So example number 2, let's use a just different color again, says solving a nonlinear system by substitution. So we've done substitution before, but we haven't done it with quadratics. So it says solve the system by substitution. The first step, it says substitute the y equals equation into the first equation. So y equals into the first equation. So negative x plus 4 minus 1 equals x squared plus x. So I'm just copying down the information. And then the next part says to simplify. So I put it in parentheses just in case I had to distribute or anything, but here I didn't have to, so I'm just going to rewrite it. And then I'm going to simplify if possible. And here I'm able to put the 4 minus 1, so negative x plus 3 equals x squared plus x. And then the next step says write in standard form and factor. So standard form is ax squared plus bx plus c. So I'm going to move over a couple of things here. So negative x plus 3 equals x squared plus x. All I'm doing was copying the information, and now I'm moving things around. So plus x on both sides to get these x's together. And then minus 3 to get the minus 3 on the other side, because I want it to look like this. So then this is all gone, and I have 0 equals, and then I have x squared plus 2x, because this becomes 2x, and then minus 3, because there's nothing else for that to go with. So the reason why I moved everything from one side to the other was because I wanted it to look like this. So then it says to factor it on that step. So to factor, you can use your tables if you need to, or your head, or Google. We've talked about this before. So if you need to take your tables out, you can do that now. I'll give you a couple seconds. Hopefully you can find them quickly. I'm going to take a sip of Gatorade. So to factor this, we get x's, and we know we need to multiply to be negative 3, but add to be positive 2. So the only factors of negative or 3 are 3 and 1, and then we want to become 2. So positive 3 minus 1 will become 2. And then the next part, and we know this equals 0, right? Because that's what we're getting there. And the next part says solve for x. So x minus 1 equals 0, and x plus 3 equals 0. So then we add 1 to both sides. We get x equals 1, and then we minus 3 from both sides. So we get x equals negative 3. So then that was like the hard part, I would say. And now it's just keeping things organized. So the next part says substitute your x's back into the equations to get y. It doesn't matter which equation you use, just like substitution before. So I'm going to just use the easiest one, which I think is the second one, but that's up to you. So I'm going to take this one and plug it into the second equation, and this one and plug it in the second equation. So y equals negative 1. Sorry, that wasn't negative 1. Plus 4, and then the other one is y equals negative 3 plus 4. So then I get y equals negative 1 plus 4 is y equals 3, which went with that, and then y equals 3, because that became negative, plus 4 is 7, so y equals 7 went with this one. The reason why I put them with the other piece that it goes with is because that's what I plugged in originally to help me find it. So now step 7, it says write the solution as points. So 1, 3 comes from here, and then negative 3, 7 comes from here. So looking at the last question for a second, if we go back, I don't know what just happened there, sorry. This is just like looking at the 2 points where they intersect on our graph. And oh my gosh, I'm like going everywhere. These are 2 points just like the same situation where they're intersecting. It just looks different because we're looking at it algebraically. So now we're going to do one more practice question with substitution, and then you're going to have some homework to work on. Hopefully you'll have time in class to do it. So following the 7 steps, the first step is we're going to substitute. So we're taking x equals or y equals and plugging it into the other one. So this, we're going to plug it in for y. So x minus negative x squared plus 3 equals negative 1. So that was step 1. And then step 2 is to simplify. So we're going to distribute that negative. Remember, it's distributing the negative 1. X plus x squared. And then negative 1 times positive 3 is negative 3 equals negative 1. So then the next step is see if we can simplify anymore. We cannot. The next step is to write in standard form and factor. So standard form, remember, is ax squared plus bx plus c. Well, currently this is not in standard form. So let's rearrange. X squared plus x minus 3 equals negative 1. And then we want to put that negative 1 on the other side to make sure it is equal to 0. So x squared plus x minus 2 equals 0, because that's going to cancel out there. And remember, we want it to look like this and have no equal sign. Oh, no equal sign on the other side. So then now that we have it look at standard form, we're going to factor it. So you can use your tables if you need to. And we're looking for a factor of 2. 2 only splits up into 2 and 1. You can also write 1 and 2. And we want it to add to be positive 1. So the 2 has to be positive and the 1 has to be negative, because 2 minus 1 is positive 1. We don't want it to be negative 2 plus 1, because that would be negative 1. So we've factored it. And then the next step after that is step 5 is solve for x. We have 2 equations we have to solve for x. X plus 2 equals 0 and x minus 1 equals 0. So we're solving both of those. That should be a pretty quick process. So once we solve both of those, this is telling us that these 2 situations, the line and the parabola, are actually going to hit each other twice, because I'm getting 2 answers here. So then going back up, the next step said substitute your x back in to find y. So I'm just going to use the first one just because I decided to. So I'm going to put negative 2 minus y equals negative 1. And then for the other one is 1 minus y equals negative 1. So then I'm going to solve each of those for y. So I'm adding 2 to both sides on this first one. Negative y equals 1. Divide both sides by negative 1. Y equals negative 1. And then, sorry, I just want to make sure I got that right. Yep. And then in the other one, we're going to minus 1 on both sides. So negative y equals negative 2, and then divide both sides by negative 1. So y is 2. So then I'm going to write my last step, which is write the solutions as points. So these go together, and these go together, and that's going to be really important on organizing your work. So I've got negative 2, negative 1, and also 1, 2 as answers. So just make sure you're very careful about keeping those pieces separated when you're solving.